Hi, my name is Miranda Kolatski, and I did my presentation on chemical changes in soil throughout the process of decomposition in order to determine postmortem interval estimation. Time of death estimations tend to be very broad and can be inaccurate because of different factors that will influence them, such as environmental temperature, body size, humidity, and the current chemical levels of the soil and the environment that the body is found. MEs tend to rely very heavily on a calculation to determine time of death, but the calculation does assume the body's temperature and does not consider the change in temperature or if the body was stored in different conditions besides the environment in which it was found. As you'll see in figure 1, there is a difference in how various temperatures the body tend to cool. The ME takes 3 main temperatures. It's the core temperature, the ambient temperature, and then forehead temperature. So the goal of this project was to evaluate the chemical changes in soil as cadavers decompose for a better estimation of PMI. In order to conduct this, I accessed Wiley Library as well as Google Scholar, and then I refined my search by using keywords such as chemistry and skin decomposition. From there, I found various articles that identified 3 key studies that all focused on experiments around soil chemistry in post-decomposition areas. So these studies were then read and analyzed in order to continue. So all of these did demonstrate an increase in both the nutrient levels of the soil as well as the acidity levels of the soil. The study that was conducted at the University of Nebraska focused mostly on the ecological setting, pre and post decomposition, and found that nutrient levels tend to increase throughout the process of decomposition, as well as the process of decomposition itself is affected by the moisture level of the soil. If it's in a thicker soil, the decomposition rate tends to be slower, whereas if it's in a thinner soil, and oxygen and other factors can get to it more readily, it will increase. Soil also does tend to become more acidic due to the release of fumes from organs breaking down and from other outside environmental factors. Ankara University and Hacettepe University evaluated the chemistry of soil as it changes throughout decomposition. They found that there is an increase in chemical levels in the grave samples and a decrease in control samples. They set up 4 different types of soil environments, which were loam grave, clay grave, organic, and sandy grave, and then 4 different control samples of the same types of soil. And they found a significant increase in the calcium carbonate levels, whereas there was not really much of a change in the control samples because their control samples were set away from the outside environment, so there wasn't any environmental factors like there were in the grave samples. The final study was done at Texas State University, and it compared the differences in various soil and water environments. This was done by placing pig cadavers in various environments, and they were checked periodically over the span of about 6 months. You can actually see the experimental setup over in figure 2. It was also found that there's increase in the acidity levels and nutrient levels in the soil, and that water tended to yield less nutrients in the soil environments in this study. Overall, all 3 of these studies analyzed and demonstrated that there would be some type of change in the chemistry of the soil, which would result in lasting effects. This research, once furthered and expanded on, could provide numerous advantages to offices in smaller areas that might not have the advanced technology to analyze every different aspect of the soil like there are in larger metro areas. And it could also potentially spur experiments and further investigations for a more in-depth analysis of the environmental factors and how decomposition truly affects these in the long run, as well as how postmortem interval estimations could be significantly improved on. Thank you.